Dear students, see the next one from 11th standard, motion and straight line chapter. The new topic is position, path length and displacement. Okay. So generally, the position means it will be represent the place. Say for example, one particle is there. The particle is, for example, here. This, simply, that's position. Okay, suppose the particle, maybe it is like a car. Okay, now this car. Okay, so now it will be change its position from here to then here. Okay, so now this is a path length. Okay, so we are going to explain the path length from this simple example. Okay, so what is a path length and the displacement we are going to explain. Okay. See that. So before going to discuss this path length and the displacement, we should know some important point, one technical word, that is reference point. Okay. Say for example, let us take this chalk piece. Okay. Now I am standing in one row. Now this chalk piece is here. Okay. So this chalk piece, okay, from the camera to here, the position is something. At the same time, from the board, some distance. From the ground, some distance. From the roof, some distance. So this is some reference point. Okay. So now, from this idea, I am going to explain. So let us take the same thing. It is like the drone. Okay. So it is the drone. Now I consider this chalk is here. So inside the hall, it is here. Okay. So from x-axis in what distance? From y-axis what distance? And from x-axis, z-axis what distance? Okay. So that is represented by. It is like some rectangular coordinates. Okay. That means what? X, y, z coordinates. I have to represent that position. That is reference point. See that only I written here. A rectangular coordinate system consisting of the three mutually perpendicular, okay, so that is x-axis, y-axis and z-axis. Okay, so by using this idea, so we can say that the rectangular coordinate system consisting of three mutually perpendicular axes labeled, that is x, y, z and x-axis. Okay, right, this is the so that is the point of intersection of these three axes is called, that is origin. It is serves as the reference point. Okay. Okay. So from the origin, the point is here. Okay. From this origin, so that origin is there. Okay. In the hall, that origin is there. So from that origin is here. Okay. So from the origin, the distance between that origin to this point. Okay. Now, how I know this point? Generally in the graph you mention, x comma y. Like that, in the rectangular components I can write, it's a point, near the point I can write in bracket x, y, z. That means what? From x, what position or what distance? From y, what distance? From z is what distance? So that is the position of this point. Okay, that is the reference point. Okay, right. The next one, the frame of reference. Okay, so the frame of reference is the same thing only. See that the coordinate system along with the clock constitute the frame of reference. Okay, it will be mentioned with the time factor. Okay, that is a frame of reference. So the frame of reference mostly we can study about what is that theory of relativity. Okay, okay. So in the theory of relativity, say we are using this word familiarly. We are using the frame of reference. Okay, even the study of the relativity, okay, the frame of reference will come. Okay, the motion in the straight line, frequently we are using this word. Okay, right. Now let's come for that first point, that is the path length. Okay, path length is nothing but distance only. Okay, by using a simple example. Okay, for example, let's take a car will travel from the origin something. Okay, see that for explanation purpose I can write in meter. 0 and 40 and 80. So each and every division is I mentioned as 40. Okay, so here 0 point is here. Then after that 40 I increase. Then 240 here. Then after that that 240 I mentioned by Q, and then 360 I mentioned by P. So like that is going in there on x-axis. Okay, now it is my reference point. It is my reference point. That is a O. Okay, that is like origin. Let's say take the origin. Okay, then in x dash axis minus 40, minus 80, minus 120. So in the minus 120, I mentioned one more point is R. Okay, so I want to explain what is the distance. For that purpose only I draw this diagram. Okay, so for example, from O to B, let us imagine that car will move from O to B. This is like a linear path, not like a curved path. Okay, so O to B. அப்போ O இருந்து P வரைக்கும் இது வரைக்கும். Okay, so from here to here. Okay, so here to here, what is the distance? So now we can say directly here 0, then up to here 360. So 360 meter. Okay, so plus 360 meter. This is plus 360 meter. So this known as, so I mentioned the same thing only. The distance is called the path length. Actually, this is travels by the car. Okay, right. Then suppose O to B, then P to Q. Again P to Q. Okay, so O to P, then again P to Q. Okay, so in this situation, what about the distance covered? So first O to B. O to B what? That is 360 meter. Then again P to Q. See that 40, 40, 40. That is 120. Okay, so 360 plus 120, 480 meter distance covered. Okay, so why I want to write this example, because the path length has only the magnitude, not a direction. Okay, not a direction. First for x it is towards the x-axis, again towards to the minus x-axis, because in opposite direction. But in the path length, no need to specify the direction, only the magnitude. For that purpose only I explain. Okay, so now you got some idea about the path length. Okay, the next we can go for, that is a displacement. Okay, next one. So path length is over. The next one, the displacement. Okay, with the same idea, I'm going to explain the displacement. See here, actually, the displacement is nothing but shortest distance between 2 points. Okay, so shortest distance means we must know initial and another one final point. Okay, so let us imagine it is the initial point. Okay, or otherwise after sometimes it is reached here, so it is initially this final. Okay, so wherever you want, in between the 2 points, okay, one is initial and another one is considered as final. Okay, right. So our convenient I can write now. So initial position. Okay, so I think okay. So see that, so initial position and time. Initial position is x1, initial time is t1. Like that, final position is x2, final time is t2. Okay, this is for our reference. Let's take. Okay, suppose, okay, x2 is greater than x1. x2 is greater than x1. Okay, I mean final position only, initial position only அதிகமாக இருக்கு. அப்போ what about that change in position? So I can write the change in position, that is x2 minus x1. அப்போ இது higher value வருது. For example, இது 100 x2 is 100, then x1 is for example 80. So automatically we can get plus 80, plus 20. So it should be the positive value. That is the meaning. Okay, suppose அப்படி இல்லாம x2 value is less than or okay, x2 value less than something, the less than value. Okay, so if it is a less than value means what happens? So it's less value minus the higher value, so answer automatically into the negative. Okay, அப்போ என்ன சொல்றாங்கன்னா டிஸ்பிளேஸ்மெண்ட்ல கண்டிப்பா நெகட்டிவ் டேர்ம் இருக்கு. Okay, நெகட்டிவ்ல இருக்கு. Okay, but distance is not negative, but displacement may be the negative. So for example, the same diagram, the object moving from O to B, the forward direction is in the forward direction, where O to B, see that O to B. So what about the distance covered? 360. Okay, so the same thing, so plus 360. Okay, so this is like as what is that path length. அப்போ இந்த ஸ்ட்ரெயிட் லைன், லீனியர் ஸ்ட்ரெயிட் லைன் பாத்தில் டிஸ்டன்ஸும் சேம் தான், டிஸ்பிளேஸ்மெண்ட்டும் சேம் தான். ஸோ தட் இஸ் மீனிங் ஹியர். ஓகே, Suppose P2Q, see that O2P already over, now P2Q. So P2Q, see that it is towards to the, what is it, negative x-axis. So it is opposite. So how much distance here covered? 360, I mean 20, 20, 20. Sorry, 40. 40, 40, 40. So 120. So in the opposite direction, so I can write the minus 120 meter. Okay? Okay, because it has direction. Displacement has direction. So for that only, we mention as the negative sign is indicate that the direction of one-dimensional motion. Okay, which is useful for the vector rotation also. Okay, right. But we don't want to use vector rotation here. Okay. Okay. In the next chapter, we are going to explain about that. Okay. So it is like opposite direction. That's all. Okay. Then the next one, the same diagram. Okay, we are going to discuss same path length and displacement simultaneously for separate for same situation. Okay, so this situation already we discussed in the path length. Okay. Okay, in which situation, the same thing, in which situation the path length and the displacement will be the same. Okay, for example, it is like in a straight line path, the straight line path. In straight line, it's not written back, let us imagine. Okay, only the straight line, it's not written back in the straight line. Okay, so in the straight line, the curved distance and the displacement will be the same. So that is the heading. Path length is equal to displacement. When? See that from O to B, the car moving from O to B, O to P. So here the distance also 360 meter and the displacement also 360 meter. So path length also 360 and the displacement also 360. Okay, right. So this is one idea. And then the second idea, suppose the car moving from O to B and turn back to P to Q. Car moving from O to B and turn back to P to Q. Okay, so here what is path length and displacement? Path length, how much will come? So first O to P, 360, then plus 120. So 360 plus 120, we can write 480 meter. Then what about the displacement? So the displacement, how displacements we know that the generally is the final position minus initial position. Final position is what? O to B and P to Q. 240 is the final position. Initial position is this origin. So 0. So 240 minus 0 is equal to 240. Okay. Actually he covered 480 meter. But the displacement is what? The displacement is just 240 meter only. Clear? Because the displacement means, the distance between final and initial position. Okay? So final position is 240 only. Already it is crossed at 240 and to reach 360. Again to finally stop at 240 only because it is returned back. So final position is 240, initial position is 0. So that difference is only the 240. That is the displacement. Right? So this two cases is over. Okay, more over the two cases. In third cases, is there any possibility displacement is 0 but the path length is there? Okay, so that example only next. See that here the next example, the path length is not 0 but the displacement is 0. How? See that is also example. Object moving from O to B and return back to P to O to P and return back to P to O again. First it is moved O to P and return back to, and second it is return back to P to O. Okay, so upon 360 cover, again 360 covered in back. So that is the distance. So we can say OP plus PO, 360 plus 360 is 720 meter. That is the path length covered by the object. But the displacement means what? Final position and initial position. So starting is 0, then it is returned back to the same position. So final position also same, then initial position also same. So the displacement is 0. Okay. Okay students, I hope now you understood what is the position and path length and the displacement, okay, and then some definitions about the frame of reference and at all. Okay.